Welcome to math class. We are continuing on in the Math Makes Sense 9 textbook, working on lesson 4.2, which is, I forgot to write it up here today, but it is looking at linear relations. So what we looked at last class was how we can write equations based off of patterns. Now we're going to look at how can we take equations and put them onto our, who smokes, those are not straight lines, but we put them onto our XY coordinates and looking at how a line can help us predict what certain values might be in the future. So that's what we're working on today. So without any further ado, let's go ahead and get right into it. We are starting with the example on page 166. Now, for this unit, you are going to need graph paper. If you don't have graph paper, go out and get it. These two basic functions here, the XY table and the XY coordinate plane, those are going to be what we use more than anything else in this unit. So if you don't have any of those things, you're going to be in trouble. These are the tools we use to solve these problems. So let's go ahead and look at the bottom of page 166. They have some examples there. They have an example of an equation of y equals 3x minus 5. What they also have done is they've gone out and laid out what an xy table of values is going to be for you. So 0 is going to be negative 5. At 1, we're going to have negative 2. At 2, we're going to have 1. At 3, we're going to have 4. And at 4, we're going to have 7. So what we can see here is there's a definite pattern going on. Our number is going up plus 1 every time, and we are also going up plus 3 every time. So we've definitely got a pattern here, right? What we need to do then is basically take these values and we're going to go ahead and punch them onto our graph. So what I'm looking at here is I'm going to go ahead and this right here, this section, this line all the way across here, that is our x coordinate. Numbers that go this way along the line, all right, we're going to pretend that, we're not going to pretend, this point right here is 0. So everything on to the right of 0 is going to be a positive x value. Everything to the left of 0 is going to be a negative x value. This should look familiar. This looks like the timelines, the number lines that we were working on earlier in the semester. Okay, we also have the y-axis, up and down, going this way. This is our y-axis. This is 0. Everything above it is positive. Everything below it is going to be negative. Right? That is how our XY coordinate plane works. Now, if we have to actually go ahead and put some points on here, let's look at how we're going to work. So our X value, our first one is 0. All right, so looking at my line across, 0 is going to be right in the middle. And now my second point, my Y value is going to be minus 5. So I'm going to go down, starting on this same line. I'm going to go down 1, 2, 3, 4, and 5. So my point winds up being right here. You should not be writing these lines in here. The only reason they're on there in my demonstration is so that you can actually see on screen where and how I'm counting. So our point for this one is going to be right on that line, negative 5 down. My point's a little bit lopsided, but I can cheat and I can move my table over slightly and fix it. Hey, look at that. So that is how we actually take the points from our table and we transfer them onto our chart, right? Every pair of XY values is its own point on the graph. So 0 and negative 5, it's always going to be X and Y. So this value is going to determine my horizontal, and then this value is going to be determining my vertical. Hopefully that makes sense. Let's go ahead and move on to the next example. On the very next page, so on page 167, we actually have a couple of examples here. We're going to start with the one at the top of the page. So graphing a linear relation from a table of values. So we're talking about DVDs. All right. What we have here is the number of DVDs rented, 1, and the total cost, $3.50. For 2 DVDs, it's $7. For 3, it's $10.50. For 4, it's $14. And for 5, it's $17.50. So what we've got to do is we have to start with plotting the points on the grid. So I'm going to look at my first x value, which is 1. So I've got a coordinate pair here. So I've got 1. I'm going to be moving over positive 1. And then I'm going to be going up 3.5. 1, 2, 3.5. Again, you should not be drawing these lines on your graph. I'm doing them here so that you can actually see how I'm counting on the video. Again, this one's a little bit off, but we've got 1 over 1, 2, 3. Oh, my smartboard's not aligned. That's why I'm a little bit off. Okay, that's point number 1. Point number 2, 2 and 7. So I'm going to go 2 over 1, 1, 2. I'm going to go 7 up. 1, 2, 3, 4, 5, 6, 7. So my point is right there. Once again, I have to go to my small eraser point, but I'm going to get rid of that line. It's only in there so that you guys can see how I'm counting. Okay. If we want to look at it as if we were doing an equation, so we have to look at this as plus 1 and this as plus 350. We can also notice that I can move, or I can predict points based off my movement. So I'm moving plus 1 on the x-coordinates. That means I'm going to be going plus 1 that way. And then I'm moving plus 350 on the y-coordinate. So now I'm going to start here. I'm going to go up another 3.5. 1, 2, 3. We'll call that a half right there because my grid ran out. Right? So that's how we put the points on the grid. Now, what we have to do is test out whether or not this is actually a linear relation. Oh, I lost one of my points there. Got a little bit too crazy. 1, 2, 3, 4, 5, 6, 7. Okay. You're going to need a straight edge for this, or if you've got a smart board like me, you get to do the fancy line like this. So I'm going to start drawing my line here. Okay. Now my line isn't perfect. I'm going to actually, oops, started drawing too many things on here. I'm going to get rid of this and draw a better version of that line. Okay, so I'm going to start here. Ooh, actually, I don't want it. Let's go back to my line. I'm going to start a little bit above it, and I'm going to try and line up as best I can so that all 3 of those points are on the same line. If all 3 of those points are on the same line, this is a linear relation, which means that there is a pattern that this line right here has a consistent pattern to the point where I could actually predict what numbers are going ahead in the future. And that is where these equations come in. Because if I can write an equation for a line on a graph, on a graph, I can go ahead and predict what those values will be, even if, for instance, your graph is not necessarily long enough to see exactly where it is. I can still predict what my values are going to be. So that is how we graph a table of values onto a coordinate plane. Now I'm going to pause here for a quick second, and we're going to do another example from, okay, just had to do a quick rearrange of my smart notebook here. So we're going to do another example from that page right below it. Now what they've done is, instead of giving you a bunch of x, y values, they've actually given us an equation. Y equals 6 minus 3x. What do I do, Mr. Waldo? I don't have the values. Well, I have the equation. So what I can do is I can actually figure out what the values are. So I have to create a table of values for random bits of numbers. So down here they say create a table of values for the relation of values of x from -3 to 3. So I'm going to do -3, -2, -1, 0, not -1, silly goose, 1, 2, and 3. And I have to figure out what are my y values. Well, we know this already. We know that every y is going to equal 6 minus 3x. So all I'm going to do is start punching these numbers in for my variable. So let's go ahead and do a couple, let's do a couple as example. Y is going to equal 6 minus 3 times -3. Y equals 6 minus -9. Those become positive. 6 plus 9. Y equals 15. Go ahead and look like that. Then we go ahead and do the same thing with the very next x number in the table of charts. So I'm going to punch -2 in. Y equals 6 minus 3 times -2. Y equals 6 minus -6. And my y values, when those become positive, my y value is going to become 12. 12. And I can keep doing that for each of these numbers. Let's go ahead and look at one on the bottom of the chart. Y equals 6 minus 3 times, we're going to steal this bottom one down here, 3 times 3. Y equals 6 minus 9. Y equals -3. So 3 and -3. In order to then draw the line that then matches with that equation, I just take these points and I plop them over on my line. So let's start with, I will do -2 and 12 because I'm fairly certain that my grid only has 10 squares. So I count over, 1, 2, and then I go up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We'll pretend that that's 12. Not overly accurate, but we'll go with that for the demonstration. I'm also going to steal this one down here because I know it's going to fit on my chart. So I have 3 and -3. So I'm going to start counting here. 1, 2, 3, and -3. 1, 2, 3. I'm going to go ahead and plot that right there. And then all I do, pull out my straight edge, and I start drawing my line. And there we go. I've now created a linear relation, a line on an xy coordinate plane off of nothing but a equation. All right, let's go ahead and look at one more example from the next page. All right. So page 169. Ooh. Okay, already at the bottom, I suppose. I'm going to go ahead. I'm going to copy my coordinate plane over here as well. Clone. I'm going to drag this down to use here. So on page 169, we have a kind of a multi-step problem going on here. So what they have is a student council holding a dance. The profit in dollars is 4 times the number of students who attend minus $200 for the cost of the student. So the first thing is we need to write an equation that relates the profit to the number of students who attend. Well, they already laid it out for us. They just happen to do it in English. So what they're saying is profit in dollars is going to equal 4 times the number of students minus $200 for the cost of music. So that is the equation we are working with. That's the equation that they've told us. All I did was convert from English to math. Next is I need to create a table of values. So I'm going to go ahead and start creating some numbers in here. I'm going to say what happens if 0 students show up. I'm going to say what happens if 50 students show up, and what happens if 100 students show up? Well, if I want to find out, I just have to punch my numbers into my equation. So let's do our first one here. P equals 4 times S minus 200. 4 times 0 minus 200 equals 0 minus 200. So our cost is negative $200, or the dance lost 200 bucks. Makes sense, right? If they're paying 200 bucks for music and none of the kids show up, they're probably losing 200 bucks. So that makes sense. What about if we go ahead and we try and do this with our next value in line? All right. What about 50? What if 4 times 50 minus 200 means that we have 200 minus 200, so the dance earns $0. Right, and then we can go ahead, hop on to the next step, figure out what happens if 100 students show up. 4 times 100 minus 200 gives us 400 minus 200 equals 200 bucks. Right. And then I go ahead and I start punching it onto my graph. Now my graph is a little bit small, so I'm actually going to pretend that each one of these lines is 100 bucks. We're just going to keep it super easy, right? So each square was $100, right? Going to X. So what I have here is I'm going to have my profit as my y-axis and my students as my x-axis, right? So if 0 students show up, I lose 200 bucks. There's my first point on the graph. Get rid of these other ones. If 50 students show up, all right, so I'm saying now it's half of that. If 50 students show up, then the dance makes exactly $0. So that's my other point right there. And if 100 students show up, the dance makes 200 bucks. I'm going to try and toss this into a line and see if it works. Look at that. This is, ooh, went too far. This is a linear relation. So there we go. All the skills we need to be able to use linear relations, equations, and table of values. See you in math class.